Welcome viewers, I am Venkatesan. Today my lecture is about mathematical induction. In last lectures we completed up to problem number 4. We continue question number 5 today. Using mathematical induction, prove that the inequality n less than 2 power n for all positive integers n. Solution. Let us consider the proposition B, P of n such that n less than 2 power n. Remember, here all positive integers was given, which means in basis step we can verify that P of 1 is true. On left hand side, if we replace n value with 1, we get 1 less than. On right hand side, it will be 2 power 1. We know that 1 less than 2, which is true. Hence, the basis step is verified. In inductive step, I want to assume that P of k is true for all positive integers k. That is, P of k such that k less than 2 power k. I want to prove P of k plus 1 is true. That is, to prove that P of k plus 1 such that k plus 1 less than 2 power k plus 1 is true. I consider the left hand side here. My left hand side is k plus 1 now. I want to derive which is less than 2 power k plus 1. In inductive hypothesis, I assumed that k is less than 2 power k. So this expression is less than. My first k value was replaced with 2 power k plus 1. But I know that 1 less than 2 power k where k is greater than 0. Whatever the positive integer, if you replace it with k, my 1 is less than that positive integer, which means the above expression is again less than 2 power k plus 2 power k. This is 2 times of 2 power k. So here 2 power 1 into 2 power k becomes 2 power k plus 1. This is my required right hand side. Therefore, P of k plus 1 is also true. Hence, by principle of mathematical induction, P of n is true for all positive integers n. Problem number 6. Using mathematical induction, prove that 2 power n less than n factorial for every positive integer n with n greater than or equal to 4. Remember, in the question it is clearly mentioned your positive integer starts from 4, which means in basis step you want to verify that P of 4 is true, not P of 1 is true. Solution. As usual, consider the propositional function as 2 power n less than n factorial where n greater than or equal to 4. Basis step to verify P of 4 is true, replacing n values with 4 in the above expression. So my left hand side was 2 power 4 less than 4 factorial, that is 16 less than 24 is true. Therefore, P of 4 is true. Next, in inductive step, I want to assume that P of k is true for all values of k where k is greater than 4. That is, P of k such that 2 power k less than k factorial. Next, to prove that P of k plus 1 is true. That is, to prove 2 power k plus 1 less than k plus 1 whole factorial is true. Now consider the left hand side, which is 2 power k plus 1. This will be rewritten as, we know that a power b plus c is equal to a power b into a power c. In the same manner, here 2 power k plus 1 will be rewritten as 2 power k into 2. I know that this 2 power k is less than k factorial in inductive hypothesis. So we can replace this 2 power k value with the k factorial with less than or equal to inequality. So less than k factorial into 2, that is less than k factorial into this 2 will be replaced with, I mean that from the assumption I considered this 2 is replaced, this I replaced with k plus 1. Why? Because my k value is already greater than 4. If I replaced with k plus 1 means I want to change the inequality as less than. I know that k factorial into k plus 1 is nothing but k plus 1 whole factorial. That is my required right hand side. Remember, when you are replacing this 2 value with the k plus 1, you have to remember that 2 is less than k plus 1 where k greater than or equal to 4. Therefore, P of k plus 1 is true. By principle of mathematical induction, P of n is true for all positive integers n greater than or equal to 4. Thank you.